So boys, so my name is Nyirenda. I'm actually here to present on how the gold leaf electroscope detects radiation. So the detection of radiation using the leaf electroscope depends on the ionization of the radiation particles, form of gamma, alpha, and the beta particles. So as you already know that the alpha particles are the ones which have the highest ionization energy. It means for us to detect the radiation using the leaf electroscope, it only work or it only be suitable with the alpha particles because they have the highest ionization energy. So first thing, we have to understand on how we have to understand the structure of the electroscope. So this diagram there can either be charged positively or negatively. So it's up to you. So first thing, let us talk on how we can use the gold leaf electroscope when it is charged positively. So for example, this is the metal cap and then we have the metal rod here. If the electroscope is charged positively, it means we have positive charges all over there. So first thing maybe before I go further is that this one will show that the ionization or radiation has passed through this one unless the leaf electroscope is discharged. If you were saying the leaf electroscope is discharged, it means it is now discharged. So here what will happen is that since we have charged this one positively, what it will mean that the leaf, the gold leaf and the metal cap will experience a force of repulsion, meaning that this leaf will not be attracted to the metal cap because this one is positively charged and this one is also positively charged. It means there will be a force of repulsion, meaning that this one will not be attracted to this one. So when you bring any source of radiation, particularly the alpha particles, if they are brought close to the metal cap, what will happen is that this one, due to its high ionization energy, it will ionize the air around the metal cap. So what we mean is that the electrons around the air surrounding the metal cap will be knocked off from the air. So there will be no more of electrons from the air. What will mean that the air around the metal cap will have electrons and positive ions. So what will happen is that since this one is positively charged, the electrons that have been ionized from the air will be the ones attracted to the metal cap. So it means this one now will be neutralized. If this one is neutralized, it will now make this gold leaf to fall, to be attracted to this one, since it has been neutralized or it has been discharged. In that way, you will now know. So okay, it means the alpha particles have been detected. But now if this leaf does not fall, like does not really get attracted to the metal cap, it means there are no radiations or alpha particles that have been passed or that have been detected. Now, let's say that is how you detect the alpha particles when the leaf electroscope is positively charged. In case this one is negatively charged, what it will mean is that now, since the air surrounding the metal cap is now having positive ions and electrons, this time around it will not be the electrons being attracted to the metal cap. It will now be those positive ions from the air being attracted to this negatively charged electroscope. In that way, again, it means this leaf will also be attracted to the metal cap, hence it will fall. In that way, it means the alpha particles have been detected. So that's what it means. And then there's a question.
Okay, thank you very much. You people, I think you can explain better now. I've liked it now to say that here now, actually we are saying, point to note, a gold leaf electroscope is having no charge. So you can make it or you can set it to be charged either positively or what? Negatively. Therefore, when you to see that this one is positively charged, you may look to the behavior of this gold leaf. Okay, now? So here these are two gold leaves which are placed here now, which means if they are having same charges, automatically they will be what? Repulsion. So if you see repulsion now, you can insert the what? The particle which you want to know it whether it is alpha or beta. Actually, this one cannot be used to detect gamma, because gamma, no what? No charge. Are they now? Thank you very much. A big hand to Timothy, our own president. Yeah, thank you.